Hello, and welcome to a little video about transforming linear functions. First, let's refresh on how we graph linear functions. When we're looking at a linear function, for example this one, f of x equals 2x minus 6, we get two pieces of information from it, which is actually exactly the right amount that we need to graph it. The 2 that's next to the x gives us our rise over our run. Since 2 is a whole number, I'm going to, whoops, that was unintentional, there we go. I'm going to make it into a fraction by making it 2 over 1. Any whole number can be made into a fraction by turning it into that whole number over 1. The other piece of information that I get from this function is that minus 6. That minus 6 gives me the y-intercept of our function. And that is where we cross the y-axis. Let's graph it. So the first thing I'm graphing is my y-intercept. So I'm going to make a point on negative 6. Next, I'm going to use my rise over run to get a second point. According to the laws of geometry, we need at least 2 points to graph a line. So let's do it. Rise is positive 2 over 1, so we're going to go up 2 and to the right 1. And here we have 2 perfect points. Let's see if I can get this ink shape thing to work. Success! I did it. Go Miss Gumin. Go Miss Gumin. Alright. I drew a line. It's perfect. It's straight. Exactly how it should be. But it won't let me adjust it. Well, can't always win. All right, this is good enough. I'm happy with this. Yes. All right. Now, let's apply some transformations. Oh, before that, I did want to point something out. My bad. I wanted to remind us that we have this invisible 1 that's in front of any variable. Sometimes it's even an invisible negative 1. In this graph, f of x equals negative x plus 1. What it really is negative 1x plus 1. The negative 1 gives us a rise over run. Because it's a whole number, I'm going to put negative 1 over 1. All right, my y-intercept is positive 1. I get it from over here, from that plus 1. I'm going to go ahead and plot it. And then I'm using my rise, which is negative 1, to go down 1, and my run over 1. Let's see if I can draw a nice straight line here. Or maybe not, maybe not. I'm just going to draw it freehand. Boop, boop. And there we go. That's good enough. I'm happy with it. All right. Now let's apply some transformations. First, let's do some vertical translations, which are a type of transformation. Given the function f of x equals negative 2x minus 4, I'd like us to graph the transformation f of x plus 6. Now, I'm going to write down f of x plus 6 right over here so I have more room to do my work. Okay. Now, what it's asking us to do is to take our function and add 6 to it. How lucky for us. We have, whoops, sorry, I didn't mean to zoom out. We have our function. Our function is negative 2x minus 4. So instead of f of x, I will write negative 2x minus 4, and the plus 6 goes on the outside. Okay, success! All we have to do now is combine some like terms. Unfortunately, the negative 2x is all by itself. Negative 4 plus 6, we can combine those and get positive 2. I'm going to graph this transformed one in this purple color, and my original one I'll graph in blue. All right, so let's begin. The one that I just engulfed, yes, that's a good word, engulfed in blue, we begin graphing it at negative 4. That's our y-intercept. So I'm going to plot a dot on negative 4. Here we have -2 as our rise over run. And just so I can see it a little better, this really becomes -2/1. Now we can really clearly see the rise and the run. Now because it's a -2, that means we're going to go down 2 spaces and then to the right 1. Fantastic. And now let's draw in that line. Oh boy. I'm going to do it like this. That's not bad, not bad. Now let's graph the one we transformed. The one we transformed has a +2. So that is where we're going to put our first dot. That's our y-intercept. Our average rate of change is still -2. Still our rise over run is still -2/1. So let's plot it. Down 2 to the right 1. Oh boy. Well, that didn't turn out pretty. Let's do this one more time. I believe in myself. There we go. That's decent enough. All right. So we had a transformation. We had a vertical translation happen from the blue to the purple function. Hopefully you can see that it moved upwards. The next example that we have is a transformation downwards. Okay, the one I'd like to do with you is an example of the vertical dilation of a function. Vertical dilation happens when we multiply our function. So in this case, we are doing 2 times f of x. Luckily for us, we have f of x. It is the, whoops, I meant to select the highlighter. Let's try that again. All right. We have f of x. How lucky for us. It is -3x plus 2. It's going to go right there. Let's write it in. Okay. Now in this problem, in order to solve it, we're going to have to apply the distributive property, which means we're going to multiply that 2 by everything inside those parentheses. All right. 2 times -3 gives us -6, and the x tags along. 2 times 2 gives us 4, so +4. I'll graph this one in purple, and the original one I'll graph in blue. Okay, let's begin with the original graph. It starts at 2, that's where our y-intercept is. Our rise over run, our average rate of change is -3/1, which means we're going to go down 3 spaces and to the right 1 space. And we have our line. Well, that didn't work. Let's try that again. Boop, 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 and boop, boop. All right, well, we'll just use our imagination that I drew that perfectly. All right. Next, we have -6x plus 4. The 4 is our y-intercept, so I'm going to go ahead and do a little dot on it. Then I'm going to follow my rise over run, my average rate of change, which happens to be -6/1. So I'm going to go down 1, 2, 3, 4, 5, 6, and to the right 1. Yes, these crisscross, and that's okay. Oh boy, that was an interesting line there. We'll pretend it's straight. This is a dilation because if you look pretty hard, you can see that the blue line kind of stretched to become that purple line. And that happened because of the multiplication by 2. All right. The next dilation we did together in class. If you have any questions about it, please make sure to check the notes. Ask me or your teacher about it if you have any further questions. Otherwise, have a wonderful rest of your day. Bye!